if you need to ask questions, you ask anytime, okay? Um, so, like remember what we did first, what we learned is the similar triangles. So similar triangles basically is a scale up, a scale down of a triangle. So if you have something like that, you can have a scale up version or you can scale down version. And as long as all the corresponding angles are congruent, we know they are similar. Okay. So are we good so far? If you're good, just type plus. Yeah, very good. Now, well, similarly, when we're looking for rectangle, now it's different. Similar is different. The difference is that in rectangle, we know all the angles are 90 degrees. So that won't help us. If we just all the angles are congruent, they are not necessarily in scale. And this only works for triangles because triangle has its special property. But for triangles, rectangles, what we're looking for is the ratio. So if this is 3 and this is 4, and this bigger one, say this is 9 and 12, then these two are similar. They are in scale because what happens if you look at here, 3 times 3 is 9, 4 times 3 is 12. So 9 divided by 3, that's 3. That's a scale factor. And also 12 divided by 4 is also 3. So as long as uh, this is the width, so width, the ratio between the width, the same ratio between the length, we know they are similar. And so this one is scaled up, we should go by 3. So are we good here? Perfect. And if you have something like this, so this is a 2, 2, and this one is 4, 6, then they are not similar because 4 over 2 is 2, but 6 over 2, then it's 3. That won't work. So we know it doesn't work. And another way to see if two rectangles are similar is based on the ratio of two sides. Like in this one, the length over width is 2 over 2, so it's 1. But here, the length is 6, width is 4, and that's 3 over 2. So 1 is not equal to 3 over 2, so those two are not similar. Okay, good. Okay, so now we're going to looking at two ways of scale up or scale down. Um, one is called ratio method. Okay, so that's how it works. Let's see, we have just a shape. Could be any shape. Say like this. We want scale down. This is a polygon. We want to scale down. So what we're going to do is we just pick a point away from that. It doesn't matter where to put it. So pick a point. Let's say it's here. And we draw a line to each vertex here, and one to here, one to here, and one to here. Okay, we got all of that. So now we just find, if you want to scale by half, all we need to do is find the middle point between the center um, and each vertex, then find the midpoint. So let's say this is a half. And from here to here, maybe it's here. And from here, here's half is here. and from here to here, half is here, and from there, half is there. So once we find all the points, we can just connect them together. And my drawing may not be correct, exact, but let's give you the idea. So now we'll have another version of that, which is just half of that. Good? Are we good on this one? Okay. And if you want to scale up, so what we're going to do is we're going to extend this point. Make sure use this as a midpoint and exactly the same length on that side. So find one point here and same here. Use this one as a middle point between this line and that one going to be up somewhere here. And this one we extend that and about, so make sure the distance between here to here is the same from here to this origin. And this one we're going to extend it somewhere here, and this one get extended somewhere here. So now we got points here, 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 here. So what we need to do is just connect them together. Let me try a different color. So we know this going to connect to that, and that's connect to that, and that's connect to that, and that's connect to that, and that connect to that. Good? Okay. So this is so-called the ratio method. So, and you can, now we can do half, we can do scale up to 2, but you can pick any scale you want. So that way, like say, instead of half, you take 1/3, and you can, so your scale down will be 1/3. Like instead this one go to the, go to make that 2, you could have make that into 3. So then you scale by 3. So this is one way of doing this. Another one is called a parallel method. Parallel method is like, say, if you have something like that. Okay, this one. So we go find the point in the center, and then we are going to draw the line go up there. And just use that as the center go line. Okay. So if we want to do like say 2 times, so what we do is make sure the length of this one and the length of that one is the same. So this side and this are the same length. So that way the whole thing will be twice than what's before. So once we have that, all we need to do is find a parallel line to this line. So let's see. We know we can draw the parallel lines. So we just draw the parallel line like that. And also a line parallel to this line. So parallel to this line, then parallel to that line, then parallel to this line, and parallel to this line. And then we have a scaled up version of that. Let me make sure I graph right. Good? Okay, so if you're good, okay, so now we have to ask a question, why is that? Why we can do something,
Dr. Bing,
yep.
for that parallel method, how do you make it how do you make it scale down for with the parallel?
Oh, the scale down is just like instead of you go from here, take half, go to midpoint here.
Just basically the same thing except it's the opposite.
Right. So instead extend out, you look back in. So instead, so you do find the middle point between here to and the center. That's middle point, and then you do a parallel line to that. Then do a parallel line to that. Then parallel line to this, parallel line to that, and parallel line to that. Then you got the scale down version. Good. Hello, Ethan.
Good.
Yep. So in a way, if you look at here, it actually looks like a spider web, right?
Right.
Yeah. And spider actually is pretty good at making those parallel lines. And I have no idea. I mean, nobody has idea why that. It's really, really very parallel. Uh, and but we actually can prove this is that works because we learned about parallel triangles. So let's actually, if you look closely enough, we actually got basically a lot of similar triangles. If you want to draw this one, we actually got what this and that a similar triangle, and the way we know that is because remember when we do parallel, we know this angle, these shared angles. Of course, these angles are is identical to itself, but remember this line and that line is parallel, which means this angle and that angle are congruent, and also this angle and that angle congruent. So all three angles are congruent. So the smaller rectangle going to be similar to the bigger one. Good. And similarly, we got this two similar triangles.
And then it's the same with all of the rest ones.
Right. So the all are similar triangles. And because they are similar triangles, they are in scale. Good.
Good.
And we can go back to the one here. You can find something pretty similar. And you can also find it's a similar triangle. And the similar triangle actually used a lot. Um, so if you look at here, this angle, and it's similar to this this triangle. So this triangle and that triangle, they are similar. And then this triangle and that triangle are also similar. And and this triangle and that triangle are also similar. So in a way, actually, you can prove that this and that are parallel, this and that parallel, and this and that parallel, and this and that parallel. And so they are all made of similar triangles. So the only difference is that this one we scale the scale down version or scalable version, we can put them outside the original graph. But on this one is oh on this one it's just either inside or outside. Okay, good.
Good.
Any more questions? Hello.
Are these the only two methods, or is there more methods
Uh,
for scaling up and scaling
I
down?
don't know, but so far I only see these two. There might be others, but so far that's what I see.
So which one is used more?
Which one used more? I don't know. I think it really depends on the application. Who is it? Uh, I think actually this one used more than the other one. Yeah. The nice thing about this one, once you have something there. You just expand outside if you want to scale up. But I really don't know in real life which one actually is used the better more. But to us, learning geometry is all just realize that they are all just similar triangles, right? And you see the similar triangles happens a lot, and that's why when they doing facial uh, recognition, uh, they just use little triangles, and so that way it doesn't matter uh, a person either far away, because if you have a person, you got eyes and nose, so the tip of nose and the
And they can use similar triangles to scare it up.
yep. So if you look at here, this is actually a triangle, and this triangle, if it's facing us closer, and this triangle and that triangle, as long as it's the same person, this triangle and that triangle will be similar. Or if someone is far away from us, but as long as the same person and that triangle is still. So that's how the computer can recognize people, just looking at by measuring um, the distance between two eyes and also distance to nose. Sometimes they also measure the mouth and also like the distance. They break into so many little triangles, and so they use that for facial recognition. Actually, I should be able to find a picture of that. And now, because using computers, they actually can have a database. So every time they want to search for someone, they just take a picture and look through the database. Let me see. Okay. I'll just show that one. Okay. So do you see the picture here? Hello?
Yeah.
So you see how many triangles they break in. So they just use that, and I mean, even though you have different shapes, all the shapes can break into triangles. They can, and so they can use that just for facial recognition. Good.
Good.
Mm-hmm. Okay. So, yep. So that's what we have for today. Okay.
What will we do next time?
Next time, um, I have to think about it. Uh, next time, I think I'm going to start doing some circles.
Okay.
Okay.
Will we learn about like how to make like the area of circles and perimeter of circles?
What's that?
Will we learn about like how to do like the area and perimeter of circles?
Oh, the area and parameter. Yeah, we do. Yeah. But those actually are pretty simple, the area parameters. But we are going to looking at uh, how do we actually uh, they called how to draw a triangle inside a circle. Okay.
Okay.
Mm-hmm. All
Thank
right.
you.
All
Bye.
right. Bye.
Bye.
Bye, Jessica.
Bye. Thank